Performing a no distillation run using the program name. Maximum reflux. Decreasing condenser cooling valve position. Decreasing deflagrator cooling valve position. Increasing heating stepper motor position.
Hi there, I'm Larry, sometimes known as Uncle Pleasant, sometimes known as Larry Who, sometimes just known as Smartass. Anyway, I'd like to first thank my friend Leo for posting all of the pictures and little video snippets on various social media sites, since I don't use them. I don't use Facebook. I closed that account back at the end of 2020. No desire to ever go back there or use any of Zuckerberg's other novelties. I use MeWe, and that's about it. The YouTube stuff, not even under my real name. So, yeah, I'm a ghost on the internet as far as my actual identity. But I wanted to thank him in advance for posting all that stuff on the sites that I don't use. It's generated a lot of interest. I can't believe how much interest. He has sent me, I don't even know how many screenshots of comments from people. I think I'm probably gonna put together a video just going through the comments, because there's a lot of questions in there. So I guess maybe do a Q&A video, but that's not today. While I have some free time because my allergies are kicking my butt, I have to do my greenhouse work at night since the humidity pulls the pollen down out of the air. That was a beagle that just came in behind me. So I'm lucky to actually be awake and talking right now, because the medication just knocks my ass out. But I figured I'll go over this and try to explain to people what's actually going on, and at least cover the basics of things. For starters, number one, I'm a programmer from Nebraska. Yes, I really said Nebraska. Everybody always thinks because if you're a programmer, you got to be from California, worked in Silicon Valley. You couldn't pay me to live there or in California. And you got to have all these degrees in 8x10 picture frames on the wall. I'm 100% self-taught. I've been at it for 43 years. I'm 57 right now. I got my first computer when I was 14. It was a Timex Sinclair ZX81, little itty bitty black thing. There was no public internet back then. If you wanted a program in a computer, you had to type the code in yourself, or you had to write one from scratch. Well, after enough time of typing in other people's code from Popular Electronics magazine, I got the hang of it and I started writing my own stuff. And ever since then, I've always had software development capabilities on any computer that I've ever owned. So when I say that I've been doing this for 43 years, I'm not bullshitting you. I've really been doing it for 43 years. I'm pretty sure I know what I'm doing after all that time. You wouldn't believe how many times I deal with people who think because I'm self-taught or because I'm from Nebraska, I can't possibly know what the hell I'm doing. Surprise! I probably have more experience actually doing this than experience that other people have in their email signatures with these random uppercase letters saying that they have this certification for this or that. And I'm like, great. You memorized answers for a test and you probably forgot all that shit the next day because you don't work your brain that hard on that topic at once you've got the certification. So yeah, certifications don't impress me at all. Anyway, what we have here, this is just an iPad connected by Wi-Fi. The smart still controller that I've developed runs on a Raspberry Pi. That's what this little tiny board is right here. What it does, okay, let me back up a little ways. My friend Leo that posts this stuff on Facebook and other places for me. He had Still Spirits T500 still and column, while I still had a 5-gallon stainless steel milk can pot still type still, what didn't have reflux capabilities at all. I liked what he had better than mine because, you know, if you do things not by the book, you could do reflux or pot still. If you just follow their instructions out of the, you know, use it according to their rules, it's a one-trick pony. It's a reflux only still, and the way they market that still, and people buy that, and I swear all they do is make sugar washes, you know, to make white lightning, and then they mix essence bottles in with it to make different things, from whiskeys to rums to you name it, schnapps. But if you follow their rules, you're really limiting your knowledge and your experience as far as home distillation. So I got tired of running that still manually, because even with the regulator that they sell, you're always chasing the needle valves. I'm going, you know what? With all the software that I've written in my life and things that I've automated, I bet I could make a computer run that thing. And I did. So the little Raspberry Pi here, this looks complicated, but keep in mind, this is all prototype stuff. This isn't something that I would expect to be on the retail market, which I wouldn't do anyway. I'm not interested in doing any retail stuff. But the Raspberry Pi monitors temperature sensors. There's one on the boiler, there's one on the column, and I reverse my flow on the deflegmator on here, so I plug the hole where the temperature sensor normally is. Not sure if you can see that on the camera, probably not. I'll show you. I'll do a jump cut and show things up close. But between monitoring those 3 temperature points with this Raspberry Pi, controlling these cooling valves, and then also controlling a stepping motor or stepper motor, however you want to word it, on an SCR power controller on the boiler, I can make the Raspberry Pi run the still accurately every time. If I find a setting that I like, which I can do with the software here, create a program. Say that, well, like right now, I have it set to one called maximum reflux. That is strictly for white lightning. No flavor whatsoever. Strip out as much water as possible. So maximum reflux. This thing will run the cooling and the temperature down here, and I guarantee this thing will, or still, will put out between 185 and 192 proof reliably every time. And I don't have to run any valves. So that's why I did it. If you look at the market, there's companies that sell automated stills, Genio and a company called iStill. They both make them. Let me grab something. I'll be right back. Okay, I'm back. I should have grabbed this before I started the video. I planned on it, but hey, I'm 57. I forgot. I'm old, all right? My friend Wayne Herbert, who has ozarkstillworks.com, you should check out that website. That guy is one hell of a coppersmith. When I first met him online, I mentioned this whole concept of building an automated still, because not everybody can choke up the $14,000 for a 13-gallon Genio or iStill. Granted, they're nice. They have an oil-jacketed boiler. You can't beat that. I mean, you'll never scorch anything, and the temperature is rock solid stable. So I asked him if he knew of any books, since he tends to be kind of a bookworm. He has a lot of books on brewing beer and other things. So I asked him if he knew of any books or information sources on automated stills, and he gave me a link to homedistiller.org. I don't use that website either. God, that's a cesspool. And somebody posted something on there about this book on designing and building automated stills, and I actually got this off of Amazon. Someone posted a review of the book on there, and it covers all kinds of stuff for automating a still. So between what I know about programming and automation and what I learned from this book, thanks a million, Wayne, I came up with this. Wrote the software from scratch, from the ground up. There are no third-party libraries in there. I don't use third-party libraries anyway, never have. You never know what's in somebody else's code. You use somebody else's code to take a shortcut, bang, you just introduced potential bugs into your project. And if you don't know precisely what they did, even though you have the source code, you may not ever figure it out. You have a bum project after that. So no, I don't use third-party libraries. I've always built all of my own from the ground up. The third-party libraries that you see online, there's quite a few of them out there. I did write, so there. So between this and my code and all that, and like I said, running the valves and the temperature control, there's another beagle. Maybe might have turned around when she saw the door. I've been able to automate this, and we'll get down to this part down here that's not in the camera's view. Digital hydrometer that I built. I actually built two different types. One of them, let me grab this. First one that I designed used no moving parts, but what I used, you can see that, that's a Flex Fuel E85 sensor off of a car. Well, brand new, I didn't steal it off a car. Come on, dog, come in or stay out. These work great, but they're really not an ethanol sensor. They're a liquid density sensor, kind of like an oscillating U-tube, which is what's used inside of those $2,000-$3,000 handheld alcometers that they use in distilleries, but very limited as far as its range. And it's not very accurate once you get air in there. If there's no air in there, they work pretty good. But the problem is you'll always have air in there, and you'll trying to evacuate it out while you're doing a still run. No. That's just not a good design plan. Who wants to be running their still and then sitting there shaking their digital hydrometer to make sure they got all the air out in order to get an accurate reading? Bad plan. So I came up with a new one, a new design. Still measures liquid density, but it measures it the way Galileo demonstrated it back in the 1600s, saying his little demonstration. I'll show it in another video later. If a person is hanging from a scale, they weigh a certain amount. Once you submerge them in water, still hanging from the scale, they weigh less. Well, the water makes you less dense, more buoyant, and it does the same thing with any liquid. Your density changes depending on the density of the liquid that you're in. So ethanol is less dense than water, so if you have a reference weight hanging from a load cell, a digital scale, in distillate as it's coming out of your still, the higher the proof, the heavier that ball is going to be. The lower the proof, meaning more water, the lighter that the ball is going to be. So that's what the new one works on. But let me switch the camera around so I can do a close-up view of things, and I'll be back in just a second. Okay, we got the camera switched around here, and it's handheld this time. So what we have here, you'll see that the proof on the hydrometer reading randomly jumps around. That's because I have the digital hydrometer in test mode. It's hard to explain. I can get to that in another video later. Serial communications between the hydrometer and the Raspberry Pi over here. I need a constant stream of data without running the still, so I have the hydrometer in test mode, so it constantly cycles through the proof. If we tap on the menu there, you can see that you can edit programs, calibrate the valves, configure the sensors, configure your heating. If you're going to use automated heating, you don't have to. calibrate the hydrometer. Disable speech. Yes, just like George Duncan's talking parrot head, this system talks too, as you noticed by the intro to this video. And then we can start and stop the runs here. I reset the database, so I only have one program in here right now. Timeline, I haven't fixed or finished that yet. That's going to show charts of your actual run, so you can see a true timeline of your run and then tweak things if you need to. All right, let's get over here to this. This is the fun part. And like I said, don't let it intimidate you with all the wires, because this is just prototype stuff. This isn't production. Prototypes, you always have wires running around. In production setups, you use printed circuit boards so you don't have to deal with that. So up here we have a Raspberry Pi with a header on there that provides screw terminals for the GPIO bus. So I can just put wires in there, tighten down a screw. This down here, this is the controller system boards, whatever, for the valves, the servo valves. And there's really nothing special about this. I have 4 LEDs on here to show me the direction of each one. Red for closed, green for open. This little board that's on top of it is what actually drives the motors. And laughably, that is a motor controller that is commonly used in RC cars. I needed something that could control motors forwards and backwards reliably, and that fit the bill. Next to that over here is a power breakout board, and that's just what it sounds like. It's a breakout board for power sources on here. So we have 5-volt lines over here. These are ground terminals. This is a 3.3 volt bus. And these are what they call, if you look down here, you see little resistors on the board. Those are pull-up resistors for the limit switches on the valve motors. So I can tell if a valve is all the way open or all the way closed. You can't overdrive it, past its limits. And then this over here is a 5-volt, 8-amp regulator. Then we have a speaker up here, so it can talk to you. And above that, it all runs on an old laptop power supply. I'm kind of a pack rat when it comes to stuff like that. If a laptop blows up, I always keep the power brick. They always come in handy for something. In this case, the 19 volts that comes out of it goes straight into here, gets knocked down to 5 volts, which feeds this, and the 5 volts gets knocked down to 3 volts with that little regulator. But also the 19 volts is what feeds the valves here, and this board down here, which is a stepper motor controller for the heating. The heating can be used with either an SCR controller, or if you buy a bigger stepper motor that has more torque, you can use it to run a gas valve. So hey, that's handy. This up here is my interface board that my temperature sensors connect to, and then the power for the digital hydrometer and sorry, the serial communications line for the digital hydrometer, and that is down here. Now it looks kind of goofy, but it's like this for a reason. It's so I can take it to another friend's house and use it on his still that has a 2-inch column, and these things where I have the net pots in there. That part just clamps onto his column, so it has a place to hang. The distillate line from the condenser goes in here, which is has a flow sensor. Not sure we can see in there, barely, but you can see the cup has a stainless steel ball hanging in it, and that ball is suspended from a load cell, which is what digital scales use. So it's a 64-gram stainless steel ball, and it changes weight depending on the proof. It may lighten the weight of that ball by 3 to 4 1/100ths of a gram. So it's pretty easy to stay right on track. You can see the display on that is weird. It draws slow, and it's because that's what they call an SPI interface display. That's the only thing I could find that would work. Can't use parallel displays, but it works. It just looks kind of goofy. But that's the digital hydrometer. Now as we go over here to the still spirits. Still, you can see that's where the temperature sensor normally goes that they provide. The water's running through the deflegmator the wrong direction in their setup. So I have the water coming in the bottom, that's plugged, and then comes out the top. Up here, I have a T connector. At the very top of it, there's a temperature sensor in there, and this is a 3/8 inch T, so the inside is a 1/4 inch in diameter. It actually fits on top of the 1/4 inch copper fitting. So the water comes up, it actually runs into that temperature sensor on its way out. And the same way, that's the normal direction for the condenser cooling waters. You always want your water coming in the bottom and working the way up. I understand why they did it in their stock out of the box design, because the water goes in, the condenser comes out, loops over to the deflegmator, goes the other direction. It works, but it's not exactly a smart design. But we have, as you can see on the back side here, here's a temperature sensor midway on the column there. And then down here, there's also a temperature sensor midway up the boiler. Now I don't have to know precise temperatures. I know the outside temperature is a little cooler than the inside temperature, but it doesn't matter. I still have constant reference temperatures to deal, that I can read and work with. And then my discharge water comes out, goes to a T, and then goes to a blue hose that either goes outside, or in the wintertime I plan on saving the water in the 5-gallon buckets and taking it out to the greenhouse. Down there you can see I have an SCR controller for the power stepper motor on the potentiometer, so I can run the temperature up and down. And over here I have the still spirits regulator, which is still necessary. Number one, I'm on a well, and even though I have a pressure tank on the well, there's like a 10 psi grace period in there from where the switch kicks on and then where it kicks off. So my pressure's, the human brain might think the pressure is constant, but it's really not. So I still use the regulator to make sure that my water going to my valves, these two, is constant. And that's what we have for the Raspberry Pi Smart Still Controller. And as for the question, why am I doing an open source thing rather than a retail thing? Well, I don't want to deal with retail. I will sell assembled boards, the modules, so people can put them together. If a person isn't comfortable with soldering, I'll happily do that and sell the 3D printed parts. So like the valve, that black thing that it's inside of, that's 3D printed. The power brick, that mount, that's 3D printed. The interface over there. Every one of these circuit boards has a platform under it that's 3D printed. That just, it makes it easier to mount the board with these little tiny screws rather than trying to drive them into a piece of wood, because that thing that it's mounted on is just something from the craft section at Walmart. It's, I don't know what people in their crafty habits do with them, but that's where it came from. So there's a lot of 3D printed parts. Oh yeah, like even down here, this part of the hydrometer housing, like these two hunks of oak, those are cut, and then these black pieces on the end and there to create the upright pieces in the proper spacing, that's 3D printed. So yeah, I will happily sell all of the 3D printed parts, including the hose guides that you see here mounted on the wall. Happily do that, but as far as selling a completed assembled item, no intentions of doing that, simply because there's too much risk. Somebody could get one, blow the thing up, and then say, oh, it was DOA when they received it. I'd have to refund their money, and then I would get back a blown up unit that I would have to fix if possible. Depends, you know. So no, I'm not interested in doing that. But I'll sell you the boards, and you can just strip the wires and put them into the screw terminals. All of the diagrams are going to be on GitHub. Everything, the 3D models, if you want to 3D print the parts yourself, they're going to be on there. The whole shooting match, all the source code. The stuff that runs on the Raspberry Pi is primarily PHP, but the drivers for the motors are written in C, just because I need the speed. I don't want to deal with any lag from an interpreted language. It's still programming either way. I don't care what anybody says. There are some people that think there's a difference between programming and scripting. Horse crap. A C++ source code file is a script that talks to a compiler. PHP talks to a compiler. It's called a just-in-time, JIT compiler. So, don't give me that. It's not programming if you're writing in PHP. Bullshit, it is too. But PHP code for that, C code for the motor drivers and all that, and the C++ code for the Arduino or ESP32 microcontroller that runs the hydrometer. So all of that's going to be on GitHub. It's already on there, but it's not complete. That's why I haven't provided a link yet. But that's what I got. I'm going to shut this video down right now because I am really stretching this out longer than what I wanted to. So take it easy. I'll catch you around on the next video. Who knows what it'll be. Could be a Q&A. Could be more details on the hydrometer, explaining that, because I get a lot of questions about that. So take it easy. We'll see you around next time. Bye.